Good morning to all. Myself Badi Alekhya, Assistant Professor under the Department of AIML, RMD Engineering College. Today in this video session, we are going to discuss regarding informed search techniques. Before going to discuss that topic, we recall that what we discussed in the previous video lecture, what are uninformed search strategies. So it's a blind search. It does not use any information when you traverse from initial node to the final node. When coming to the informed search strategies, we followed some heuristic functions when you are going to traverse from initial state to the final state. So some of the examples regarding to informed search strategies, let us discuss in this video. Among that, first one we consider it as best first search. It's a combination of both BFS and DFS. So DFS follows a single path. So when it follows a single path, it does not regenerating the nodes and not wasting the computation time. So by considering the advantage of DFS, and when coming to the advantages of BFS, when you traverse all the neighboring nodes, there is a solution is presenting in the neighboring nodes. If the solution is not presenting in the single path, the solution will be available in the neighboring path. So when coming to considering the advantages of BFS, the nodes will not be caught into a dead ends or loops. So by combining the advantages of both DFS and DFS, we are implementing best first search concept. Including with that, what we have to consider for the informed search strategies, we are using evaluation functions. How the evaluation functions will be implemented, we will discuss with the two algorithms. First one is greedy best first search and second one is A star search. So let us look at this example, a sample graph which consisting of visiting of all cities, and the straight line distance is here. The straight line distance is nothing but h of n values, a heuristic straight line distance values. So when you are going to traverse from one node to the another node, that cost we are called it as path cost. That values we consider it as g of n values. So why I mention h of n and g of n, you come to know in the next slide how it will be useful for calculating function cost. So when come to discuss about greedy best first search, it's also minimizing the route path by considering estimated cost. So in the previous slide I explained this is the graph and this is the straight line distance values. So here the distance, the path with distance from node to node, we consider it as actual cost. Here what are the values you are giving as a straight line distance to the destination, we call it as estimated cost. So when you are going to work with greedy best first search, you concentrated on estimated cost only. So let us discuss with example how the estimated cost will be useful in calculating or traversing the path from source to destination. So let us discuss with the example. We start with the initial state arrayed. Here in this example I consider my source is arrayed and the destination is Bucharest. Go to the graph. What are the neighbors for arrayed? The neighbors for arrayed are Sibiu, RDO and Timsaro. So for this value don't consider the actual cost. Under greedy best first search you have to consider which cost? We have to consider heuristic cost, that is estimated cost. What is the estimated cost for Timsaro, Sibiu and Zaran? The estimated cost for Timsaro is 329, Sibiu is 253 and the Zaran is 374. Let us see. So what are the heuristic costs for Sibiu? 253, Timsaro 329 and 374 Zaran. How greedy best first search will expand the node now? After expanding the node from the root, which one having the minimum estimated cost, that node value has to be expanded. So among these three nodes, which one having the minimum h of n values? So CBU has at minimum h of n values. There from CBU you have to expand the nodes. From CBU how many number of nodes expanded? Again look back at the graph. From CBU you can expand it to audio, you can expand it to arrayed, and you can expand it to MSU Vilicia, and you can expand it to Fagrasas. See, that is expanded for ARAD, FAGROS, audio and MN-VLCO. So again the same condition among these 4 nodes, which one is having the minimum cost, minimum estimated cost. So FAGROS has the minimum estimated cost 176 we have to consider. So from where we have to expanded the node, from FAGROS we have to expanded node. After expanding the FAGROS, the tree will be like this. So from FAGROS where we have to expand, look at the graph again. From FAGROS we can either extend it to Bucharest or you can either extend it to Sibiu. What's our destination? Our destination is Bucharest. So we have to mention like this, Sibiu and Bucharest. So already we know what's the h of n values. H of n, that means estimated cost value for Sibiu is a 253. And Bucharest, what is the estimated cost? Look at the table. What is the estimated cost for Bucharest? It's a 0. So there you have to consider Bucharest. Among these two, which one is having the minimum value? 0. Therefore our destination goal is reached. In this way we are going to apply our greedy best first search algorithms. Okay, in order in this algorithm we are just estimated the cost when we are traversing from source to destination. So but it may be vary, the traversing cost may be vary. To avoid the drawbacks, we are moving to A star search algorithms. That means total estimated solution. We are going to provide the best solution for the best in best first algorithm. We are using A star search algorithm. What's the difference? What's the difference between A star search algorithm and greedy search algorithm now? Here when you observe the evaluation function, that function cost will be calculated in greedy first search. We consider only h of n value, but when come to A star search algorithm, we consider both h of n values and g of n values. What is h of n value? Already we discussed. What is h of n value? It's the estimated cost values. And when coming to g of n value, what's the g of n value? It's the actual path cost from start node to the n node where we are traversing. Let us we see how we are going to calculate f of n values for the same graph and the same heuristic values, that straight line distance values, how we are calculating this f of n, how it is going to be implemented A star search algorithm. Let us see the same graph we have considered here and the heuristic values for this thing. Remember, when you are going to calculate the node distances in greedy search, you just consider this straight line distance value only. But when you are going to implement for the A star search algorithm, you consider both straight line distances and you also consider both actual path cost. Okay, let us see how it's going to be calculated. Same, what is the initial state here? Arad. What is our destination? Is a Bucharest. How it is going to expand? Let us see. For Arad, what in the previous example we see, for Arad what are the neighboring children? Sibiu, Temsero and Zeran. I will explain how this value will be calculated. So for Arad, what are the neighbors? Sibiu, Zerad and Timsario. And for Arad, what is the actual cost? 140. So what is this value? G of n value. For Arad, you have to consider, and also we have to consider which values? Straight line distance values only. See? So G of n value is 140. Sorry. G of n value is 140. For CBU, what is the straight line distance value? H of n value is a 253. So what is the formula for calculating function cost value for the A star search algorithm? By combining both actual cost and heuristic estimated cost. What is the actual cost for CBU? 140. What is the estimated cost for the CBU? 253. By joining these two, we will get the function cost value. What is the value here? 143 plus 253. See, Here for CBU we calculate the functional cost 393, that is the combination of both g of n value plus h of n value. For CBU what is the g of n value? 140. And for CBU what is the g of n h of n value? 253. By combining these things, what is the value will be generated, what is the function cost will be generated? 393. For same Timsaro like that only. Timsaro, see for Arad Timsaro 118. For Timsaro what is the h of n value? 329. So g of n value is 118 and h of n value is 329. See, g of n value is 180 and h of n value is 329. What's the total functional cost? 447. Like that you have to calculate for each and every node. I will explain after node expanding how you are going to calculate f score values for the given node. In this example, the three for CBU, among these three, which one is having the minimum value? CBU is having the minimum value. That node you have to consider first, 393. So we have to expand the nodes from this. In the previous greedy search algorithm itself, we calculated what are the neighboring nodes for CBU: Arod, Fagros, Ordio and Rimonia Velsia. So when coming to discuss, I will tell for Arod how it is going to calculate. For Arod, how it is going to calculate? Just observe carefully. You have to take both paths. From Arod to CBU, what is the g of n value? From CBU to Arod, what is the g of n value? So for Arod to CBU, what is the g of n value? 140. Again from CBU to Arod, what is the g of n value? 140. So 140 plus 140, what is the value? It's a 280. And then what is the heuristic value for Arod? 366. So now 280 plus 366, it's a 646. I will explain with another node, children also. Look at it carefully. From Arod to CB, when you are going to calculate g of n value, you have to consider entire paths. So what is the path value, actual path value from Arod to CBO? What is the actual path cost from Arod to CBO? Move back there. So Arod to CBO, it's 140. So 140. Again from CBU to Fagros, what is the actual path cost? It's a 99. It's a 99. So 140 plus 99, it's a value of 239. And then what is the heuristic value? What is the straight line distance value of Fagros now? Straight line distance of Fagros, so 178. So 236 plus 1, so 176 so printing mistake, so 176 we have to calculate. Both combining both, you will get the value 415. Same like audio, we calculate for audio. Let us we will see how it is going to calculate. For RDO, from CBU to RDO, what is the cost? 151. Actually we have from CBU, for where you will get CBU? From Arod to CBU, for CBU to Fagros. So for Arod to CBU, it's a 140. From CBU to Fagros, what's the cost? From CBU to Fagros, it's a 99. Combining these both, and you are going to add with the heuristic straight line distance value. Sorry, there you can get this value. So the combining the values of Arad to CBU distance and CBU to Oriode distance, by combining both these g of n values and add with h of n value, you will get the value 671. So same like this you can repeat up to reach the destination. The same concept when you are going to consider Arrowhead, Fagres, Ordio and Remolicio. Among these four, which one is having the minimum value? So Romanio will see. So you have to expand this node. Same thing, but you should be careful when you are calculating the g of n value. Don't consider directly g of n value from CB to R node or CB to Fagnes. You have to consider entire path cost for calculating g of n value plus the heuristic value which is present under the table. In this way you have to calculate the solution for the A star search algorithm for reaching the destination. That's all in this video, ma. I think it's clear for you people. Try the remaining nodes and calculate the F score value for each and every node. So the here what is the condition you have to remember for greedy first search? We have to follow f of n equal to h of n. There we can depend only on these heuristic values. When you are going to solve the problem under A star search, you concentrate on both actual cost values and the heuristic estimated cost values. The other name for this straight line distance values are estimated cost values. So be careful when you are going to solve this path cost g of n values. If you are calculating g of n values for CBU to Fagres, now you won't consider the g of n values from CBU to Fagres. You have to consider the entire path value. RR to CBU, what is the actual cost, and CBU to Fagres, what is the actual cost. These two actual cost plus heuristic value of that particular Fagres. So in this way you are going to solve your A star search algorithm. So same path, the same conditions we followed. Among this which having the minimum value, this node you have to expand up to you reach your final destination. I think it will be clear for you. So in the next videos we will discuss the remaining informed search strategies. Thank you.